Hi, here I'll be talking about heat exchanger. A heat exchanger is a device that allows two moving fluid streams to exchange heat without the two having to come into direct contact. All heat exchangers do the same job, passing heat from one fluid to another. But they work in many ways. The two most common kinds of heat exchanger are the shell and tube and plate or fin. In shell and tube heat exchangers, one fluid flows through a set of metal tubes while the second fluid passes through a sealed shell that surrounds them. Plate heat exchangers have lots of thin metal plates with a large surface area to transfer heat between fluids. An example of a heat exchanger is a car radiator, which is used to regulate the engine's temperature. Water that cools the engine flows through the radiator, which has lots of parallel aluminum fins open to the air. As the car drives along, cold air blowing past the radiator removes some of the heat, cooling the water and heating the air and keeping the engine working efficiently. But how is this possible? Let's talk about the first law of thermodynamics.
The first law of thermodynamics is the application of the conservation of energy principle to heat and thermodynamic processes. There are two parts to the first law of thermodynamics. The first one being conservation of mass, followed by the conservation of energy. Starting off with conservation of mass, the law of conservation of mass states that matter, in a closed or isolated system, cannot be created nor destroyed. It can only change forms, but is conserved. The second, conservation of energy, states that energy cannot be created nor destroyed. It can only be transformed from one form to another. Now, let us apply the first law of thermodynamics to better understand the principles of a car radiator. A car radiator is an example of a steady flow process with heat transfer mechanisms. Therefore, we will apply mass balance for steady flow processes, as well as energy balance, incorporating heat transfer mechanisms into the explanation. Mass balance for steady flow processes. During a steady flow process, the total amount of mass contained within a controlled volume does not change with time. Hence, the conservation of mass principle requires the total amount of mass entering a controlled volume equal the total amount of mass leaving. For energy balance, the net change in the total energy of the system during a process is equal to the difference between the total energy entering and the total energy leaving the system during that process. By incorporating heat transfer mechanisms, the above equation then becomes: for a steady flow process, since thermodynamic properties of the system does not vary with time, the rate of change in total energy of the system becomes zero. The total energy entering the radiator then equals the total energy leaving the radiator. Since there is no heat transferred, neither is there work done. They are then eliminated in the equation, leaving us with mass flow energy. Derivation of mass flow energy. Energy for a simple compressible system consists of three parts: internal energy, kinetic energy, and potential energy. The fluid entering or leaving the controlled volume possesses an additional form of energy, flow energy. Hence, the total energy of a flowing fluid becomes, which gives us our equation for mass flow energy. Since kinetic energy and potential energy are negligible during this steady flow process, we can cancel them out, leaving us with the following. The above equation can then be used to solve for the mass flow rate or enthalpy within the system, or in our case, the radiator. We hope you find our video informative. Thank you for listening, and as always, don't forget to leave a like.